let's do an example. Let's take the surface area of e to the negative x from x equals 0 to x equals 10. First step would be to draw it, right? So we'll have exponential decay. And by the time you get out to 10, it's looking pretty small. And we're rotating around the x-axis. I forgot to say that. So we'll get another version of it down here, and we'll get kind of a trumpet shape here. So what is that surface area going to be? Go ahead and write the integral using the surface area formula. So maybe write it generically first. A to b 2 pi f of x times root 1 plus prime of x squared dx. And then specialize it to this situation. From 0 to 10, 2 pi e to the negative x square root 1 plus, what's the derivative of e to the negative x? It's negative e to the negative x because of the chain rule, dx. And does that look friendly to solve? Well, we got something inside here, and we've got something like it on the outside. What do you think? Maybe u substitution? So u equals, what would you use here? Well, you could use 1 plus e to the x squared, 1 plus negative e to the negative x squared. Another way we could think about it is just this inside part. That turns out to be kind of a little easier. We can ignore the negative because the squaring is going to cancel that anyway. So let's just use e to the negative x, and then du equals negative e to the negative x dx. So negative du equals e to the negative x dx. And oh, look at that. I've got an e to the negative x sitting there waiting to combine with this to give me e to the negative x dx. Handy. All right. And we could solve this two ways. We could convert the limits to u territory and then just plug in, or we could do it all, do it in u, then take it back to x. Let's do the second one. So let's do it as an indefinite integral. So we'll go integral 2 pi, the e to the x combines with the dx to give negative du. So I'll leave that out for now. 1 plus u squared, like that. And then we got times negative du. And is there anything we can do with that? Got to think about that. So maybe you've thought about it a little bit. It turns out it's possible to integrate, but not with the techniques we know yet. Maybe we'll see some of the techniques later in the semester. I found a table of integrals online, so let's go look at that. All right, here's a table of integrals online. It's at Paul's Math Notes, which is a common site. And it says the integral of some constant squared plus u squared du equals this interesting thing. Where's a log coming out of that? Maybe we'll see that later. So we're not going to finish up this problem and actually get an answer. It's just the process of setting up the integral, maybe doing something to it to put it in a slightly more familiar form, and then if we have to, looking that up in a table of integrals.